Okay, thank you very much to the organizing committee here for inviting me to give this presentation. So my name is Charlotte Lauridsen. I'm from Aarhus University in Denmark. And my presentation is entitled From Oxidative Stress to Inflammation, Redox, Balance and Immune System. So most of my research has been really focusing on pigs, but since it's a poultry conference, I'll try to draw in poultry as well. So the content of my lecture today is as a starting point to show for you that we have some major challenges in pig and poultry production. Then I'll continue to try to emphasize when and why livestock may suffer from oxidative stress and inflammatory reactions. And then I'll continue on the dietary influence on redox status of the animal. I will focus on fatty acids and immunity, and then antioxidant deficiency and immunity, and supplementation of antioxidants and immunity, and finally some conclusion and perspectives. So the challenges in our pig production. You may know that Denmark is really producing a lot of pigs, many more pigs than people in Denmark, and we have kind of spread out our genes towards the world. So we are having these hyperprolific sows. They are giving around 20 piglets per litter, but these litters, they are very heterogeneous, and we are facing a high piglet mortality. So this is a critical phase of life, but also weaning from the sow is a stressful period for the piglets. It has to adapt to new feed and environment. It is getting separated from the dam, which is also a psychological stressing factor. And during this period, the post-weaning period, there is really an increased risk of enteric diseases, which means that we have a high consumption of antimicrobials during this part of a piglet life. And in Denmark, we are currently using, instead of antimicrobials, the super nutritional levels of zinc. But from an environmental perspective, this is not a good thing to do. So today, we are really looking for alternatives to antibiotics and zinc. So this will kind of be a starting point of our research today, is really how can we improve resilience and robustness of the piglet. Just to demonstrate what I have said so far in some numbers. So we have this survey, DanMap. You can look it up. This is a yearly report on the use of antimicrobial agents and occurrence of antimicrobial resistance in bacteria from food animals, food and humans in Denmark. So already in the 90s, we gave up using the antibiotic growth promoters. And since that time, this was actually before the ban in the European Union. So we have reduced this, but also you can see that there has been a steady increase in the use of prescribed veterinary antimicrobials. Still, we are producing more and more pigs in Denmark. So today, we are really saying, what can we do to reduce this antibiotic usage? And what we have today is this yellow card initiative given to the farmers if they are using too much. The thing is now that the majority of the antimicrobials in the pig production, that really goes to during the post-weaning period. Around 85% of antimicrobials is really being used for treating for enteric diseases in the post-weaners. Recently, we have had this debate on the increase in veterinary microbials because of the multi-resistance bacteria. And now we're also putting focus on medical zinc. So this is just to show for you that the diarrhea, that's the frequent observed gastrointestinal illness in pigs. The most outbreaks occurs during the second week post-weaning, the post-weaning diarrhea. Morbidity can be really high, up to 50%. And mostly the cause is the enterotoxigenic E. coli. Stomach ulcers is also an important inflammatory reaction, but so far we are not really sure about the impact of bacteria here. Maybe it's not the cause, but a contributing factor. What you should see from the pictures here are really clear clinical signs of inflammatory reactions during these diseases. Also, just to show for you the problem with the zinc, the consumption of zinc oxide, the supranutritional levels of zinc has increased, and this is really because we couldn't use antimicrobials so far anymore. This is critical, and we have to do something. We also see the challenges in the poultry production. I should say now that Denmark is not really a main producer of poultry. So this illustrates also here that this segment of the livestock production is not the major contributor to the use of antimicrobials. What we use of the antimicrobials for in the poultry production is the treatment of coccidiosis. This disease is characterized by oxidative stress, inflammation, diarrhea, nutrient malabsorption, fluid loss, and dehydration. So there are other inflammatory reactions in frequently observed diseases in broilers. The dysbacteriosis, it's not a well-defined inflammation of the small intestine, but it occurs in the period 21 to 28 days, and we have the necrotic enteritis, which is a severe intestinal inflammation occurring almost the same time. And here we have the major contribution by the toxin-producing Clostridium perfringens here. Now, these infections, and we have, in my research group, had major focus on gut health and disease prevention. Now, these infections triggers an inflammatory response. It's basic knowledge here that the bacteria trigger macrophages to release cytokines and chemokines. And we have, during this process, a release of inflammatory mediators. Later on, you see the vasodilation, vascular permeability, and then the influx of phagocytes. Fortunately, this is a reaction going on. It's a natural host mechanism to combat with invading pathogens. What is now the link of infectious disease to oxidative stress? Well, there was a question here about what is antioxidants. We have seen so much today by the former speakers about oxidative stress. My eyes, it's the imbalance between the production of the reactive peroxides and oxygen radicals, and then the scavenging ability of the host to destroy them. So the question is now, when do we, or now the animals, produce the reactive oxygen species? It's not only during the elimination of foreign material by immune cells. It's actually a part of normal metabolism, as also demonstrated by Walter during the first presentation. But the high genetic potential under intensive farming conditions may actually elevate the production of these reactive oxygen species. Here you can see again how the bacteria are being engulfed by the phagocytosis, which is now really how the bacteria is going to cope with the invading bacteria, but the very important mechanisms by which the macrophages and other immune cells are going to kill the bacteria. It's just to illustrate here that these oxidative, reactive oxygen species, they are so important to use for the immune cells to kill the bacteria. These are the weapons. And as we have clearly seen, that the highest production of reactive oxygen species are going on in mitochondria. And the thing is, if we can't control this, it may lead to a mitochondrial dysfunction, and this has actually been proven, especially in human diseases, to be a link towards a disease progression. I think it's very interesting with some recent research carried out that also the genetic factors, such as intensive genetic enhancement seen as the production cycle for broilers, has been shortened to 35 days. And this can actually also be related to an increased production of reactive oxygen species, and also the improvement, or you can talk about improvement, but at least genetics towards more lean pigs. But these pigs, they have abnormally high serum concentrations of reactive oxygen species as opposed to rural swine. And it means actually that you have oxidative stress conditions during resting, similar to that of human during intense physical training. So it means we should really keep an eye that this genetic progression may lead to a higher level in general of oxidative stress. Now, going further, the redox balance and immunity. It is possible to actually, by nutritional modulation, to enhance the resistance to infectious diseases. And this is especially Klasing, who has been here, maybe still is around, has demonstrated that deficiency of fatty acids, vitamins, and selenium may actually lead to damage to the development of immunity, and there are direct regulatory actions of these nutrients. So I have, during my research, asked myself, how can you actually, by dietary manipulation with fatty acids, vitamin E, and selenium, what kind of mechanisms and effects would it have on immunity in pigs? So what you can see from this figure made by Professor Klasing is that you want to be here in the, I don't know if you can see it, yes, you can see the red spot here. That's, this is really the region you would like to be in. You don't want to be during a deficiency situation or a toxicity. Both would actually influence the immunity of the animal towards a critical situation. We have not discussed that much today about fatty acids, but the thing is that these inflammatory reactions, they are really related to the level of arachidonic in the cell membrane's phospholipid region. So once arachidonic acid is getting liberated by phospholipase A2, it produces prostaglandin E2, and this is performed by the cyclooxygen enzymes. And this process is important, not only in inflammatory reactions, but also for wound healing. But here you can see that in parallel, you can also have the production of reactive oxygen species. Everything here is a natural and important reaction, but if it gets out of control, it is really enhancing the disease progression. And this is why it is so important to try to control it. I'll just in a few moments demonstrate how this is possible by fatty acid manipulation, and then here how you can also use antioxidant therapy to inhibit these reactive oxygen species production. It's really interesting with the research performed where you have combined the N-6 and N-3 fatty acids. It is very easy by dietary means to manipulate the cellular composition of fatty acids. And although, if you see here that from linoleic acid, you get a production of arachidonic acids, and this, as I just showed for you, will actually produce eicosanoids, which are heavy inducers of inflammatory reactions. But here, if you now take the alpha-linolenic acid, that you can, by chain elongation and desaturation, also have a production of eicosanoids. And although they're very similar in molecular structure, they are less important initiators of inflammation. So here is to show for you that we can actually play around with the ratio between C18-free and C18-2 in the diets. And often we have done a lot of research to see if we can actually influence the production of the longer chain polyunsaturated fatty acids by inclusion of more C18-free, but it is not that easy. Just recently, we performed a study with hemp oil versus soybean oil. Unfortunately, it was not the funny hemp here, it was industrialized hemp. We produced oil out of this. And although when fed, hemp versus soybean oil, you see here that you change the ratio between N6 and N3, higher in soybean oil, lower for hemp oil. But although these sows, which we sampled blood and milk, they were fed hemp, soil, and oil without any of the longer chain polyunsaturated fatty acids, EPA, DHA, and so. We were not able to detect anything in the oils of the feed, but these fatty acids were present in colostrum and milk and plasma of sows and in the piglets' plasma. So, as also demonstrated in other research studies, these fatty acids are important for the piglets, for instance, in order for the mucosal immune responses to appear. And I think that maybe we should keep in mind that the fatty acids are probably those which are the biological most important signals for the immunity. The antioxidants are not behaving in the same way, but they should, again, they are there to control the oxidative stress reactions, but the fatty acids are those who are actually influencing the cytokine production and all the other signal molecules important for the immunity. There are many ways by which nutrition diets can modulate intestinal ecosystem. The fatty acids, of course, are only part of it, but I think one of the major important things are that you can directly influence the composition of the immune cells in the intestine. Some of the nutritional products, prebiotics, probiotics, maybe they change more the microbiota, and I know there are a lot of studies now addressing probiotics, but again, interestingly, the fatty acids are those which have a direct influence on the immune cells here. So we have, since we know that it's not possible to get the EPA DHA produced by inclusion of vegetable oils rich in C18 and C3, we have included fish oil in piglet studies, and there you can see that if we now study the fatty acid concentration of the gut mucosa in 56 days old pigs, that's 4 weeks after weaning, we really see a changed fatty acid profile of the gut mucosa here. And when we now start to put a challenge on the immune cells, here it's macrophages harvested from the lungs. This is more easy than harvesting macrophages from the gut. And you can see that you can actually influence the production of eicosanoids here, the PG2. Actually, the fish oil to the weaners inhibited the production of PG2 in comparison to the sunflower oil and also animal fat. But of course you should keep in mind that once you start to play around with the fatty acids in the diets for the animals, you can really influence also the susceptibility to oxidation, because oxidation rate depends on the number of double bonds. And you can see you have a factor from 1 to 2004 going from C18 up to C18-free. So this is why we need to control this reaction. Now, when we start to put a challenge on the animal, we activate the immune cells, and once they are going to be called for, they change in order to increase their antimicrobial efficiency and development of immune response. This I demonstrated later on, or earlier on. You see this increased production of oxygen-derived products. So the dietary antioxidants, they can actually help to limit collateral damage by the free radicals to the host tissue. Now, you have already heard a lot about, I'm happy about that, because vitamin E is still, in my eyes, the most important biological antioxidant. It is sitting there in between the fatty acid in the cell membranes, and it prevents the oxidation of the fatty acids in the cellular membranes. And the way it does that is to donate the hydrogen to the peroxide radical. In that way, you terminate the reaction. Now, we have at our institute several animal models. One of them is now E. coli inoculation to pigs. And interestingly enough, you can see here that irrespective of the vitamin E level in the feed, it was either given on a control level or a supplement level. You can see that once you start to challenge pigs with E. coli, you actually reduce the vitamin E concentration in the liver of pigs by approximately 30%. Recently, we in this hemp study, we have confirmed these results, and we actually observed a reduced plasma vitamin E concentration in pigs after an E. coli inoculation. So what is going on? Again, I think that once all these processes, I said to you that once the invading bacteria is coming into the intestine, there is this reaction of a reactive oxygen species produced, and then there is a need for more antioxidant protection, otherwise the gut tissue would be destroyed. Fortunately, There are not only one antioxidant, vitamin E, but there are several of them already. We have heard about the glutathione peroxidases, the superoxide dismutases, vitamin E, C, and so forth. This interaction you also heard about by vitamin E and glutathione peroxidase. This is a bit simplistic because glutathione peroxidase, we now know it's not the only one. We have 25 selenoproteins. And again, there is a nice collaboration between vitamin E and then the more water-soluble, the enzymatic antioxidants sitting there in the water phase of the membrane, and in that way they can scavenge and terminate the out-oxidation processes. Now, when is it actually a critical situation? When do we have vitamin E and selenium deficiency, and what is now the link to immunity? It has been observed for a long time ago that when a diet was depleted in vitamin E and selenium, you saw suppressed lymphocyte response to mitogens compared with vitamin E and selenium depletion alone. Again, it was said by Lizard here that the key may be the fatty acids. Suppression of the immune system might be attributable to oxidative products from fatty acids. Antioxidants may prevent or inhibit proliferation of lymphocytes and alterations in the immune cells. The critical phase, as I said in the beginning of my presentation, is really during the post-weaning period of a piglet's life, because while it's suckling the sow, it is getting a lot of passive lactogenic immunity factors. Once we wean the piglet, there is a steady decrease, and since the piglet is weaned maybe too immature, it is still not having an active immunity. We have seen this in one of our studies that actually already at day 4 after birth, I mean the pig is born vitamin E deficient, but 4 days after, the sow has transferred so much vitamin E through the colostrum that the vitamin E status is built up. Then we wean the piglet, and you can see that vitamin E is really decreasing here. This has to do with the limited capability of the piglet to absorb fat-soluble nutrients and also vitamin E, and there is often a limited endogenous synthesis of vitamin C during this period of life. So in my eyes, we really have to address this period of a piglet life because this is where you see a severe oxidant stress condition if you don't have enough antioxidant protection. Now it is possible to treat the piglets with vitamin E, and in that way build up the vitamin E status. You can see here we had increasing dietary levels of vitamin E, and we followed the pigs 4 weeks after weaning. It's defined in the literature that when you're below 0.6 milligram per liter plasma, it's a so-called deficiency situation. Here you have a critical condition. Some authors are talking about that in order to have the best immune status of a piglet, you need to have at least 3 milligram vitamin E per liter plasma. However, I think we need more results to demonstrate that. But based on my own research, I would say you can say that an E. coli infection really costs in antioxidant concentration measured as vitamin E here. So it means that you can easily suddenly be in a critical situation. There are studies around where, but unfortunately you can say that they are rather old now, and they are not really performed on the same production conditions as we have today. Again, the genetic material has changed and also the production systems. So although there are some results showing that increasing levels of vitamin E would actually enhance immunity of pigs, I think we need to again put more focus on this research. We have seen that if we supplement sows with increasing levels of vitamin E, we actually saw an effect on the antibody response to E. coli of the piglets. And also we have seen with piglets weaned from sows fed different sources of vitamin E, but also different levels, that vitamin E had no impact on the cellular mediated immune responses, but in that experiment we also had different fatty acid compositions, and those were actually the players, those were making the differences in immunity. So Professor Mahan has contributed a lot to the research in pigs concerning organic and inorganic selenium for sows. And as already said, that the organic selenium forms are making or are giving a higher selenium status than the inorganic forms. But the reason why we have focused so much on this from a nutritional point of view is really that in order to have a piglet post-weaning with a good selenium status, you need to influence this status via the sow feed. Because pigs of poorer selenium status encounter the selenium deficiency sooner after weaning, as demonstrated by Mahan. And depletion of selenium reserves with advancing parity is also something which has been emphasized by Mahan, simply meaning that increasing parity of the sows would actually put a pressure on the selenium as well. So what about supplementation of vitamin E and selenium and immunity? It is well documented that alpha tocopherol status can be increased by increasing vitamin E. And we have also focused a lot on the differences between natural and synthetic forms of vitamin E. And also that the selenium status can be increased by using especially organic selenium rather than inorganic. But so far very little is known regarding the influence of enhanced antioxidant status on immune responses of pigs post-weaning when the infectious risk is high. So the role and mechanisms of biological important forms, selenoproteins, tocopherol derivatives, I think that is important. So coming to the conclusion and perspectives, what I started out with is that we think we should keep in mind that are really challenges in the pig and poultry production, the use of antibiotics towards infectious diseases, that oxidative stress and inflammatory reactions are part of normal defense mechanisms against pathogens, but also that oxidative stress may be enhanced during intensive production. We need to control these productions, the oxidative stress production and also inflammatory reactions to prevent tissue damage during infections. And there are several mechanisms by which we can actually control it. And I think overall If we focus more on this, optimal antioxidant nutrition may reduce the need for antibiotics by increasing the robustness of the animal towards infection. But we need certainly more research on that. So finally, I'd just like to show for you a picture of our institute and of Denmark and my group. And if you don't know where Denmark is, I probably think you know, but you will soon find us in the world map, because just close to our institute, they are building up a new Apple data center in the middle of nowhere, but that's also where we are situated. So with that, I'd like to thank you for listening.